Hello everybody, we start with the next chapter in chemistry for standard 9th ICSE, and that is study of gas laws. So that's the 7th chapter of Viraf Dalal textbook, study of gas laws. Now before we start with the study of gas laws, we need to understand the gases. Now we very well know, we have studied in the previous classes, the previous standards also, that gases are those kind of substances which do not have a specific volume, they do not have a specific shape. So the volume wise they take the volume of the container. So अगर मेरे पास, like for a simple example would be, if I got the DO, so DO के अंदर के जो fillings है तो वो, or even the room freshener, if the container is so small and it has got all the gas inside, but the moment I spray it outside, it is taking the space of the whole room. So you can see that the gases can expand to innumerable times depending upon what is the pressure available to it. So it takes the shape of the container also, so it doesn't have a specific shape, nor it has got a specific volume. So it is seen that with the change in the volume, in the pressure or in the temperature, there will be a subsequent change in the volume. So the interrelationship of the volume of a given mass of gas with its pressure and the temperature. So with the increase in pressure, what happens to the gas? Whether it will expand or contract. तो हम लोग का मालूम है कि हम लोग गैस को अगर हम लोग compress करेंगे, pressurize करेंगे, तो वो छोटा हो जाएगा. That means that increase in pressure decreases the volume, and decrease in the pressure increases the volume. That is one thing. Secondly, what we know is with the temperature, as I increase, when I heat something, what is going to happen? It is going to expand. So gases को तो और भी भागने का time मिलेगा. So if I increase the temperature, the volume increases. If I decrease the temperature, the volume decreases. So this relationship which is there is what we are going to study in the gas laws. So the relationship of the gas laws, and we also with the of the volume of the gas with the temperature and the pressure, and also we are going to study some basic properties of the gases. So let's start with the chapter. Gases have certain properties which differentiate them from solids and liquids. The three states of matter are solid, liquid and gases. Gases differ from solids and liquids in the following ways. Gases do not have a definite shape or volume, as in case of solids and liquids. Liquid do not have a definite shape. So gases are are the state of matter in which they do not have a definite volume, neither their definite shape. Liquids, they do not have a definite shape, but they do have a definite volume. Solid, they have got both definite shape and definite volume. The distance between the molecules is much larger in case of gases, comparatively less in liquids, and almost negligible in solids. We know that thing. Solids के अंदर tightly packed, liquids के अंदर थोड़ा loose, gases में एकदम free. The force of attraction between the molecules is negligible in case of gases, comparatively more in liquid, and maximum in case of solids. Of course, they are quite tightly packed because the force of attraction between them is much higher. ये दूर है तो force of attraction is less, and ये बहुत दूर है तो force of attraction is negligible. So gases में force of attraction between the particles is negligible. Molecules of gas move in a straight line, undergoes random collision with other molecules, and occupy the complete space available in the container, unlike solids and liquids. So unlike solids and liquids, they can move around anywhere in the room or anywhere in the particular container. That's why they are going to occupy the whole space available to it. So that is about the main properties of the gases as compared to liquids and solids. Now let's see the behavior of the properties of the gases, behavior and characteristic properties of the gases with respect to the kinetic theory. So behavior and property of gases can be explained by the basis of kinetic theory. First one, behavior and property is gas occupies no definite shape or volume. So gas occupies all the space available in the that is shape and volume of the container in which they are filled. So kinetic theory explains it this way. The molecules in a gas are far apart and the force of attraction between the gases molecules is very weak. Molecules are in continuous motion in the entire available space and their movement is restricted only by the walls of the container. Hence they take the complete volume of the container because molecules are not attracted to each other. There is no force of attraction between the molecules. That's why they are just randomly moving around and the only thing to stop them is the container walls. High compressibility, the volume of the given mass of a gas can be easily compressed to much smaller volume by increasing the pressure upon it. So, yeah, obviously because there is so much of empty space available between the molecules of the gas. So we see that high compressibility, the volume of the particles negligible. The volume of the particles negligible compared to intermolecular distance. Hence can be compressed, then it brought closer to each other because maximum volume of that particular gas particles is very having no substance at all. So there is nothing in between, and because there is nothing over there, so it can easily be compressed. Third part, exert pressure in all directions. Gases, unlike solids and liquids, which exert pressure only in a partial downwards, exert equal and uniform pressure on the walls of the container. That you can easily note by a balloon also. When you blow a balloon, the pressure is equal in all the sides of the balloon. So that's right, exert pressure in all directions. Kinetic theory point of view say, impact of gas molecules with high velocity causes pressure to be exerted on the wall. So because there is an impact of the gas molecules are moving around, तो उसका volume, उसका जो molecule is going to dash against the walls of the container. So that is the balloon or maybe that particular part. So that's why it is going to exert pressure on the walls of the container. The same number of molecules strike on a given area of the wall in unit time. So that's why it is going to be exert equal pressure in all directions. Fourth point is have low density. Obviously, because the mass is negligible compared to the volume, so density is definitely very, very low. Gas is much lower density compared to solids and liquids. Under ordinary pressure, conversion of a given mass of solid to liquid to a gas causes a much greater increase in volume than the original. Hence, the density of gas is very low compared to the solids and liquids. So, based on the kinetic theory, the intermolecular distance between the molecules of the gas is very large. Hence, the number of molecules per unit volume of a gas is much lower compared to the solids and liquids. Gas therefore have very low density. Okay, it's very, very simple because the mass is very less and the volume occupied is very high. So density is mass upon volume. Obviously it will be very low. Diffusibility or miscibility. Gases diffuse readily and when kept in contact with one another, combine completely forming a homogeneous mixture. Okay, gases can mix along or get along with the other gases very easily because there is so much of space available between them. So that's why they are able to mix around very easily. They do not need any kind of a conflict between each other. So you can see that the space between the molecules of gases is very large since the intermolecular distance between the gas molecules are large. Hence the gas molecules have a tendency to mixing with other gases molecules. The speed of movement depends on the mass and temperature of the gas. So this is about the explanation of the properties of the gases based on the kinetic theory. Now let us start with the gas laws, but before we move with that thing, we need to understand some basic physical quantities on which the gases are going to be dependent upon. So gas laws are certain rules which a gas follows when subject to a change in temperature, pressure and volume. The effect of change of any one of the above parameters affects the other two parameters. For example, volume of the gas undergoes significant change if its pressure or temperature is slightly changed. The parameter are described in the table shown below. So, you know very well that the pressure, temperature and volume are interconnected to each other. A small change in any one of them, there will be a drastic change in the other two. So that's why it is very much co-related to each other. So let's see how they are correlated. First of all, temperature. Temperature is an indicator of the average kinetic energy possessed by the molecule. Kinetic energy increases with the increase in the temperature. So what is temperature? We know very well it is the average kinetic energy present in that particular gas. So average kinetic energy will depend upon its movement, the gas ka movement. Now gas ka movement जो है, as soon as it is heated, what will happen? It will be more vigorous. So definitely the kinetic energy is directly connected to the temperature. Hence we see that the temperature is connected to the movement of the gas molecules. So the units of temperature is very important. So the temperature is measured in degrees Celsius or Kelvin. Okay, we are going to have it in degrees Celsius Kelvin. Relationship between degrees Celsius and Kelvin is that the value, or we can say K plus 273 degrees, sorry, K is equals to degree Celsius plus 273. Okay, value of K is equals to value in degree Celsius plus 273. The next is pressure. Average force exerted by bombardment of the gas molecules on the walls of the container per unit area of the container, or the ratio of the force exerted on the wall to the total area of the container. Of course, we know the pressure is equal to force upon area. So what is the force over here? It is the force applied by the molecules of the molecules of the gas on the container, and of course the area will be the surface area of the walls of the container. So accordingly, pressure will be force upon area. So that is the average force exerted will be equal to the ratio of the force exerted on the walls of the of the container to the total area of the container wall. Now the pressure is going to be in terms of atmospheric pressure. So the next one is pressure. That could be in atmospheric pressure. It could be in centimeter of Hg or millimeter of Hg. It can be in torr, torricelli. And the conversion is 1 atmosphere is equal to 76 centimeter of Hg or 760 mm of Hg. And also 1 torr is equals to 1 mm of Hg. These are the conversion factors which you may require in the numericals which are there in gas laws. The final thing over here is the volume. So volume, gas has indefinite expandability and occupy the volume of the container. So yeah, it has indefinite amount of volume. It will be depending upon what kind of container I am putting into. If I am putting it into a small box, then it will take the container, it will take the volume of that much. If I like the spray can, okay, the room freshener, what is in that can? So it is everything is contained in that. अगर मैंने उसको room में डाला, room कितना भी बड़ा रहेगा, it is going to take the volume of the room. So that's why it is going to be the expandable infinitely, indefinitely. Volume of the gas is the space occupied by the fixed mass of gas. So whatever is the space occupied by the gas is the volume. So accordingly we have it, the volume will be either it will be in it is liter or dm cube or centimeter cube or milliliter, yeah, what is that, or cubic centimeter cube is one and the same thing. Yeah, so the relationship 1 liter is equals to 1 dm cube is equals to 1000 centimeter cube, and 1000 centimeter cube is equals to 1000 ml. Therefore 1 ml is equals to 1 centimeter cube. That's the relationship of the volume. So this thing's very important. You need to remember these differences. Temperature is in degree Celsius Kelvin, but in Kelvin, if it is in Kelvin, if you want to convert anything degree Celsius into Kelvin, you have to add 273 to it. Pressure is in atmospheric pressure or cm of centimeter of Hg or mm millimeter of Hg. 1 atmosphere is 76 centimeter of Hg or 760 mm of Hg. 1 torr is 1 mm of Hg. Liter, decimeter cube, centimeter cube, or milliliter or cubic centimeter, not required. 1 liter is 1 dm cube is equal to 1000 centimeter cube. 1000 centimeter is 1000 ml, so 1 ml is equal to 1 centimeter cube. That was about the relationship. Now we see about the what happens if there is a change in the pressure or there is a change in the temperature on the volume of the gas. Pressure is increased when the temperature of a fixed mass of gas is kept constant and the pressure is increased systematically, the volume correspondingly decreases. So it is something like this कि मैंने अगर समझो एक particular syringe लिया और syringe के mouth को मैंने बंद कर दिया and if I press, so what happens? There is a gas inside. Okay, I pulled it, so there is a gas inside, air inside, or maybe some gas inside, and then I press it on one side and I press the button, press the syringe. What will happen? The syringe का अंदर का volume कम होते जाएगा. So वो कम होते जाएगा उसका मतलब क्या हो? And the pressure increases, the volume decreases. So you see that if I am able to keep the temperature constant, then with the increase in pressure, there is a decrease in volume. A gas X occupies 500 ml when the pressure is 2 atmosphere and 250 ml when the pressure is 4 atmosphere. Similarly, if the pressure is decreased when the temperature of the fixed mass is kept constant and the pressure is decreased systematically, the volume correspondingly increases. So अगर मैंने वही syringe को बाद में रिलीज किया तो जैसे वो बाहर निकाला तो the volume automatically increases. So the volume is going to increase with the decrease in pressure and the volume is going to decrease with the increase in pressure. If the pressure is decreased to 1 atmosphere, the volume of the gas is 1000 ml. So that is what they have given you as a graph over here in that experiment 1 में pressure 2 था तो volume 500, pressure 1 तो 1000, pressure 4 तो 250. So that is the relationship between pressure and volume. So pressure and volume के difference क्या है? तो pressure or I'll just erase this. So pressure increase, volume decrease. Pressure decrease, volume increase. Okay. Now relationship between temperature and volume when pressure is kept constant. So when the temperature increased, when the pressure of a fixed mass of gas is kept constant and the temperature of the gas is increased, systematically the volume correspondingly increases. So if there is a temperature, when we see if the temperature increases, volume also increases. The temperature decreases, volume also decreases. With the increase in if the pressure remains constant, with the increase in the temperature, with the increase in the temperature, the pressure also. With the increase in the temperature, the volume also increases. When with the decrease in the temperature, the volume also decreases. So at a gas Y occupies 200 ml when the temperature was 400 Kelvin. It is heated to 600 Kelvin. Its volume is increased to 300 ml. Temperature decreased when the pressure of the fixed mass of gas is kept constant and the temperature of the gas is decreased slowly. The volume correspondingly decreases. So the gas Y occupies 100 ml when the temperature decreases to 200 Kelvin. So you can see that there is a linear graph. Okay, the graph shown over here means 400 ka 200, 600 ka 300, 200 ka 100. So the graph will be a straight line linear graph that is directly proportional to the. So we can say the temperature and volume are directly proportional to each other. Now all these relationship what we saw, okay, the relation between this and this what we saw was actually studied by two scientists. Okay, there were two chemists, two scientists who did the study of these particular gases and the relationship was set up by them. First was Robert Boyle. So Robert Boyle gave his law called as Boyle's law. Okay. So the first law, so we come to the first law of the gas laws, or else, we go to the first law of the gas law. So that is Boyle's law. Robert Boyle studied the relationship between pressure of a gas and its volume. The study of gas, Robert Boyle found that at constant temperature, the volume of a fixed mass of gas goes on decreasing as the pressure is increased. On doubling the pressure, the volume decreases to by half. The behavior was generalized and was named Boyle's law after Robert Boyle. So the Boyle's law states, temperature remaining constant. Now this particular statement of the Boyle's law is very, very, very important. You need to write it word to word. There are two statements given over here. You can write any of them, but they have to be word to word as given in the textbook. Okay, so mind well that you are learning it absolutely by heart. Temperature remaining constant, the volume of a given mass of dry gas is inversely proportional to its pressure. So what did he say? Boyle's law stated that the volume of a given mass of a dry gas is inversely proportional to the pressure. Because if the pressure increases, the volume decreases, and if the pressure decreases, volume increases. So accordingly, it is inversely related to each other. So that is why let a particular mass of gas occupy V volume, then pressure is P at constant temperature T, then according to Boyle's law, V is proportional to 1 upon P. So V is equals to K into 1 upon P, or we can say P into V is equals to constant. Okay, P upon V is equals to constant. That means that if a particular mass of gas occupies V1 at pressure P1 and V2 at the volume at pressure P2, then it can be given over here that according to the Boyle's law, it will be P1 into V1 is equals to P2 into V2 is equals to K. This is the Boyle's law ka equation. The equation of the Boyle's law is P1 V1 is equals to P2 V2 is equals to K. Got it? So that is the Boyle's law ka equation. Now Boyle's law can also be defined as temperature remaining constant, the product of the volume and pressure of a given mass of dry gas is constant. Yes, you can also write it this way, that the product of the volume and pressure of a given mass of dry gas is constant. So experimentally we can easily see that if the pressure is 1, the volume was 1000, so P into V will be 1 into 1000. If in experiment 2 the pressure was 2, the volume became 500, so again 2 into 500 is 1000. And when the pressure is 4, volume becomes 250, then again it is 4 into 250 is 1000. So pressure into volume has a constant value for a particular unit mass of for a particular mass of gas, dry gas. So we'll be having certain numericals based on Boyle's law, but all the numericals we are taking it at the last together. So right now we'll just have the understanding of the different laws. The next law is the Charles law. So next law is Charles law. Now Charles, so here it was given that temperature is constant, whereas over here pressure is constant. So there is no change in the temperature in this case and no change in the pressure in this case. The study of gases, Jacques Charles studied relationship between temperature and gas and its volume. Jacques Charles studied the temperature-volume relationship of gas and found experimentally for a fixed mass at constant pressure, the volume expands or contracts, increases or decreases by 1 upon 273 of its volume at 0 degree Celsius, for every degree rise or fall in the temperature. The behavior was generalized and named as Charles' law. So here the important part is 1 upon 273. What is that? That is nothing but the Kelvin scale. So that means the pressure and the temperature and volume are related to each other. The temperature and volume are going to be related to each other only when the temperature is in the Kelvin scale and not during the Celsius scale. So that's why we have the Charles law as pressure remaining constant, the volume of a given mass of dry gas increases or decreases by 1 upon 273 of its original volume at 0 degree Celsius for each degree centigrade rise or fall in temperature. So this is the definition. Of course, you can use another definition which is given down, which is slightly easier also. But yeah, this is the thing, that with each and every degree rise in Kelvin scale, there is a subsequent increase in the volume of the gas. So volume of a given mass of dry gas increases or decreases by 1 upon 273 of its original volume at 0 degree Celsius for each degree centigrade rise or fall in the temperature. Absolute scale of temperature, a temperature scale with absolute zero as its starting point is called as the absolute or Kelvin scale of temperature. Consider a known volume of gas X, volume 273 degrees 2 centimeter cube, temperature 0 degree Celsius. Its volume will rise or fall by 1 centimeter cube from every degree rise to or fall in temperature. So therefore, at 1 degree Celsius, it will be 274 centimeter cube. At minus 1, it will be 272. At minus 273, it will be 0 Celsius, 0 cc. Now, we need to understand what is absolute zero. The temperature minus 273 degrees Celsius is called as absolute zero. Reduction of volume of gas to 0 degree Celsius, 0 cc, is only a theoretical concept. Practically all gases liquefy or solidify before reaching this temperature. So absolute scale, the new temperature scale with its 0 at minus 273 degrees at each degree equal to 1 degree of Celsius is called as absolute or Kelvin scale of temperature. So the relationship will be 0 degrees equal to 0 plus 273 Kelvin. Minus 273 degrees will be minus 273 plus 273, 0 Kelvin. And 25 degrees will be 25 plus 273, 298 Kelvin. All temperatures on Kelvin scale are in positive figures. There is no negative in Kelvin scale because minus 273 itself is 0. Indicate by T is no degree sign written. So there is always T. T will never be degree Celsius. It is only T. So Kelvin में अगर कोई भी रहेगा तो it's only that T value. So it will like 275, not degree Kelvin. It will be only Kelvin, 275 Kelvin. So we can define Charles' law. So we have over here that temperature is proportional to the volume. Or we can say that volume is proportional to, or volume is equals to K into T. Therefore, volume upon temperature is equals to K. So pressure remaining constant, the volume of a given mass of a dry gas is directly proportional to its absolute Kelvin temperature. Now these words, absolute Kelvin temperature, are very important to be mentioned in the Charles' law. Okay, you cannot just say over there the volume of a given mass of dry gas is directly proportional to temperature. No, you get it wrong. You need to write over there that volume of a given mass of a dry gas is directly proportional to its absolute bracket में Kelvin temperature. Okay, so that is V is proportional to T, and that is at its constant pressure. So we have got V is proportional to T, and so if we have got V1 and T1, so we have it over here that V1 upon T1 is equals to V2 upon T2 is equals to K is your equation for Charles' law. So the Charles equation law equation is V1 upon T1 is equals to V2 upon T2 is equals to K at constant pressure. Okay, so this is the Charles' law and the Boyle's law, and finally what we have over here is about the gas equation. I think I'll take it in the next video, or I'll just complete it. Let me complete this thing so that we have got the explanation in one part and the numericals in the other part. So gas equation, the term gas equation is the equation used in chemical equation calculation for calculating the change in volume of gas when pressure and temperature both undergo a change, thereby giving a simultaneous effect of change of temperature and pressure on the volume of given mass of dry gas. In all practical situations, all the variables together changes. See, what we are trying to understand over here is that this is when temperature is constant. This is when pressure is constant. But in practical conditions, whenever there is a change in the pressure, there will be a subsequent change in the temperature. Why? Because it is not possible to maintain the kinetic energy of that particular thing which is hitting over there and the kinetic energy is remaining constant. वो possible नहीं होगा. Similarly, अगर मैं उसको heat कर रहा हूँ, pressure में build नहीं कर रहा हूँ, वो possible नहीं होता because the container cannot be keeping on expanding in the same rate as what is the expansion of the gases. So accordingly, what will happen? There will be a subsequent change in the temperature, pressure, and a subsequent change in the volume. So volume will be always changing with respect to the temperature and pressure continuously changing in both the same conditions simultaneously. Okay, both the temperature and pressure are going to change simultaneously. So the gas law the derivation will be that when we apply the so let's see the derivation for the gas equation. So we have over here that at constant volume, so by Boyle's law, so by Boyle's law, we have got volume is proportional to V upon P. By Charles' law, we have got volume is proportional to T. Okay, here temperature is constant, here pressure is constant. So at constant temperature, the volume of a gas varies inversely with the pressure. V is proportional to 1 upon P, constant temperature. Applying Charles' law at constant pressure, the volume of a gas varies directly to the absolute temperature, that is V is proportional to T at constant pressure. But on combining the two, what is going to happen? It will be V is proportional to 1 upon P into T. So if I take the K, it will be is equals to K T upon P, or we can say P V upon T is equals to K. Or best thing is we say P1 V1 upon T1 is P2 V2 upon T2 is equals to K. So this is your gas equation, which is a combination of the Charles law and Boyle's law. Boyle's law and Charles law ka combination is your gas equation. P1 V1 upon T1 is P2 V2 upon T2 is equals to constant. So let's understand the Boyle's law and Charles law even from the kinetic theory point of view. So let's see. Boyle's law, pressure and volume are inversely proportional to each other at constant temperature. At constant temperature, if the volume of the container is increased, gas molecules have more longer distances to strike the walls of the container. Since pressure depends on the frequency with the gas strikes the walls, the frequency of collision decreases, resulting in the decrease in the pressure. Similarly, if the volume is halved, the frequency with the volumes collides is doubled, thus doubling the pressure of the walls of the container. So it's very simple. We know that how is the pressure developed in a gas. Pressure is nothing but the number of molecules colliding with the walls of the container. Okay. अगर मैंने volume expand कर दिया तो automatically क्या same number of molecules are going to take a longer time to reach this particular walls, so their pressure automatically decreases. और मैंने उसी चीज को अगर छोटा कर दिया तो gases can easily collide with the walls very easily, so the pressure on the walls is going to increase. That is nothing but the Boyle's law. Let's say the Charles law. Temperature absolute and volume are directly proportional to each other at constant pressure. If the absolute temperature is doubled, the kinetic energy of the molecules also doubles, and hence the frequency with which the volume collides with the walls of the container, that is pressure, also doubles. So you see that if the temperature is going to be increased, when the temperature increases, automatically there is an increase in the kinetic energy. Increase in the kinetic energy with the way it is going to collide with the walls increases. That's why the pressure is also going to increase. So that's why we have got that वॉल्यूम आर डायरेक्टली बिकॉज उसके बाद अगर प्रेशर इंक्रीज हुआ तो वॉल्यूम भी अपने आप इंक्रीज होने ही वाला है. सो इन दिस वे यू कैन सी दैट द काइनेटिक थियरी and behavior of gases explains Boyle's law and Charles' law. The final thing over here is the STP or NTP. Okay, what we have is, write it over here itself. STP or NTP. Okay, STP or NTP is standard temperature pressure or normal temperature and pressure. So these are, whenever you got any particular kind of a numerical where it is given that the gas is at STP, that means it has got the standard values of pressure and standard value of temperature. The standard value of pressure is 1 atmosphere is equals to 760 mm of Hg, or of course it is going to be 76 centimeter of Hg. And in case of temperature, it is 0 degree Celsius is equal to 273 Kelvin. So temperature for a standard temperature and pressure condition mein, temperature will be 0 degree Celsius, the 273 Kelvin, and the pressure will be 1 atmosphere, which is 760 or 76 centimeter of Hg. Volume of gases changes with temperature and pressure, and the standard value of temperature and pressure is chosen to which gas volumes are referred. Hence volumes of the gas are converted to standard temperature and pressure conditions and then compared easily. So if I want to compare two gases, so what I'll do is I'll take it at STP. STP पे इसका क्या condition है, इसका क्या condition है, and accordingly I can compare the two gases more easily if they are at the same temperature and pressure conditions. So this was about the gas equations and the explanation of the gas laws. So we have got numericals based on the Boyle's law, Charles' law and the gas equations. So that we will take it in the next video.